All right, so today I'm asking everyone to please sign in. We are going to cover briefly the TCEQ Nonpoint Source Program. John Stone, our project manager, is going to go into detail on that. And then I will cover Chapter 4, our pollutant sources, Chapter 5, our pollutant source assessment, and briefly cover our low duration curves and our select tool that we used. And then I will go into Chapter 6, our best management practices. So let me give you sharing capabilities. Yes.
Thanks, Heather.
You're welcome.
Working. We usually use Teams, so this is unfamiliar.
Yeah, our Teams license doesn't allow anyone to phone in, so we're needing to use our WebEx license.
No worries. What can you see right now?
I see your presenter settings.
Okay, so not the slideshow. Yay. How about now?
Perfect.
Awesome. All right, I'm gonna get started. Hi, everyone. Thanks for joining us. My name is Jessica Johnstone. As Heather said, I am the project manager. For this project, I work for the Texas Commission on Environmental Quality, TCEQ. I work for the Nonpoint Source Program. We provide some of the funding for this effort. Okay, I'm going to start way back. We distribute Federal Clean Water Act Section 319 funding. It's federal funds passed through the state to you. And we say that we fund 3 different project types, so 3 different pots of money, we say. The first is developing and writing watershed protection plans. And that looks like data collection, stakeholder engagement, data assessment, and writing and approval of a watershed scale action plan. Our second pot of money we say is implementing EPA approved WPPs. So all of the WPPs that we fund run through the EPA review process for ultimately hopeful approval. And then you're eligible for implementation funds. So implementing looks like implementing the management measures or best management practices identified in the approved WPP. Education and outreach may be one of those, and then continued stakeholder engagement. So outside of a WPP area, we fund a different set of projects. It's our third pot of money. It's implementing our Nonpoint source management plan for the state of Texas. This is a big overarching document that sets the goals of our program. So anything else that may fit in that management program but is not in an approved WPP area may still be eligible for our funding. Our funding annually is about $2.5 million. We will provide 60% of the project cost if you'll provide 40% match. And right now, our project costs range approximately $90,000 to $700,000 of federal money without the match. It's lower or higher, just depending on the project. Now, what is a WPP? We all may be familiar, maybe some of us aren't, so I'll give us a little brief overview. It's a totally voluntary plan. It's a ground-up strategy, so designed with stakeholders, an action plan to mitigate surface water pollution, considering and informed by the TCEQ integrated report, which identifies impairments or pollutant concerns to water bodies, and then, of course, again, guided with stakeholder input. Because our WPPs are EPA approved and funded by EPA, we do adhere to specific standardized guidance from EPA, and most importantly, those are the 9 elements of the WPP. Forward. Here's a map of our existing WPPs. We do have a sister agency. It's the Texas State Soil and Water Conservation Board. They work in rural areas and we focus in urban areas. Sometimes those boundaries overlap, but in general, they're a more rural program focusing on agricultural and silvicultural practices. So their WPPs are in green and ours are in blue. Here's a little graphic of what the process looks like. So again, emphasizing a ground-up approach. That looks like starting with partnerships local to your area and your stakeholder group development. Once you have those partnerships in place, you'll characterize the watershed through data collection, either of your own or by acquiring data from other sources. That information will help you set goals and identify your solutions, and then design an implementation program. Sometime between designing the program and implementing your plan is your writing the plan and seeking EPA approval. Once you have that approval, you'll implement your plan, and as your implementation occurs over the years, you'll measure your progress and make any adjustments. And then later down the line, usually 5 or 10 years, we see plan updates still with the same stakeholder guidance and improvements to the new plan based on your new information. The WPP development process. So that looks like identifying your pollutant loads through monitoring and acquiring the existing data. You may, after that, model to determine pollutant sources, consult your stakeholders about the results of that modeling. You guys have been pretty involved in that process recently. And then quantifying your goals for load reduction in order to meet state or stakeholder standards for pollutant levels. Identifying your management measures, which we are here to talk about today. We also call these BMPs, it's best management practices. You'll hear that a lot on our end. You, as part of this process, will identify BMPs using the sources and estimated load reductions from your previous step, as well as stakeholder decision-making. These BMPs are going to be actions that aim to reduce pollution with quantifiable results. That's very important to our program. And then a real stickler about our funding is it cannot overlap with your existing MS4 permit requirements. In developing your WPP, you should identify a schedule for implementation. It's going to set targets for when the primary elements of the plan will be completed. And also it may identify milestones for success and include the strategy for updating the WPP in the future. It should also take into account when the resources and funding are expected to be available for executing your plan. The ideal outcome for all of us is to achieve pollutant load reductions in your watershed. So that's our goal. I know that's yours as well. That looks like assessing your BMP effectiveness once your plan is approved and you're making action on the ground. So A lot of times that looks like on-the-ground monitoring before and after implementation, or like upstream and downstream of a structural BMP. Education and outreach reductions may be indirectly calculated. We have a few examples now of load reductions being calculated through changed behaviors reported before and after education and outreach programs. The load reductions are reported to EPA through us, and they can be used to assess WPP milestones. We expect that a WPP is an adaptive management strategy. We hope for, of course, a long-term stakeholder group, sustainable for decades, to help inform updates on the plan. Again, the updates can be informed with the BPP effectiveness monitoring. That monitoring will determine if the BMPs are adequately improving and protecting water bodies, and what kind of changes or additions can be made to the plan. Okay, I have some examples and pictures of common BMPs, starting with pet waste. We often fund bag stations with educational signage to address bacteria concerns. It's very common for us in urban areas. And here's a couple of examples, not just with pet waste information, but also stormwater education with a pet waste station. If you guys select pet waste digesters, it will be the first time I've seen that, and I look forward to seeing that implemented. So the LID features, the low infrastructure development features that we fund are of course the most showy. So this looks like rainwater harvesting, the bioswales, pervious pavers, other green infrastructure projects, some of which are recommended for the Joe Pool Lake watershed. So this is a rainwater harvesting cistern. And I also have pervious pavers, really lovely design. We often fund riparian restoration and education. It's, again, another side-by-side, multiple goals achieved in one project, the restoration and the education. Of course, OSSFs to address bacteria is very, very common for us as well. We're often funding entire projects for the repair and placement programs for septic systems. So on the left, you have an example of a septic system replacement. And on the right is an example of database creation for OSSF work. Databases are used in our work often to track important information for these programs. And then these programs as well have a heavy education and outreach component. And really, nearly all of our projects have an education and outreach component. There are trainings and workshops available that we can facilitate. I know the stakeholder group has seen some of those already. They range from pretty technical to very basic trainings and workshops. Publications to be distributed is pretty common for us. Public service announcements are more common now since COVID, and seeking an alternative to in-person events. Youth outreach has been popular for us in the past and is looking to make a comeback now. Education and outreach is, we think, very important to the success of the WPPs and reminds people why we want to protect or improve these resources as well. So our program runs an annual grant solicitation period, and we commonly call that the RFGA. requests for grant applications. We just closed our 2021 cycle, so the next cycle will be summer of 2022. You can expect, if your project is selected for funding, about a year from proposal to project kickoff. Our projects start in September, so apply in summer. We'll start the following September if you're selected. And again, we give you 60% of total project cost. We want a 40% match from you. That match can come in a variety of ways. Cash, salaries contribution, in-kind contributions from your partners, volunteer hours, maybe one of those in-kind contributions, lab analyses, monitoring activities from your partners can be considered match funds. And really it's wide ranging, so if there's questions, let's ask. I'll of course answer questions today here as well. I'm done with my presentation. There's some contact info here I'm happy to leave with you. It's our general website as well as our general program inbox. We do have a listserv that sends very few emails, information about our projects, mostly regarding our grant solicitation period. No spam. So if you're interested in signing up for the listserv, just send your information to that nps@tceq.texas.gov and we'll get you on the list. That's my personal information there. And I'm available for questions if there are any.
Awesome. Thanks, Jessica.
Yeah, thank you.
Okay, so there was a few more people that signed on while Jessica was speaking. I'm going to put our sign-in sheet in the chat, a link to our modeling report, and a link to our BMP, best management recommendations. Did that? Okay. All right, share, screen 2, share. Okay, so since this is one of the public stakeholder meetings, I'm going to go through a brief review of everything we've done over the past summer. Since the majority of the summer we were meeting with the steering committee and updating, recalculating a lot of our analyses. So just a brief review of our watershed. Joe Pool Lake, it's located in Dallas, Ellis, Johnson, and Tarrant counties. We have Walnut Creek right in here. That's our sub-watershed. And then we also have Mountain Creek, which is to the south. That also encompasses Soap Creek. And we have urban, suburban, industrial, municipal, ag, and several parks as land use. And Joe Pool Lake itself is designated as public water supply, aquatic life use, contact recreation, has a fish consumption, designated use, and a general use. And so overall, the project goals are to protect the water quality in Joe Pool Lake, as well as in the tributaries, and then to improve the water quality to address the nitrate concern in the Mountain Creek arm and the bacteria impairment on Walnut Creek. But both of those have since been removed as of 2020. All right, so as I'm going through chapter 4, potential pollutant sources, please jot down any questions or comments, put them in the chat, send me an email to address one-on-one. So these likely pollutant sources in the watershed, they were identified through the historical data review, through water quality monitoring, source identification, load calculation efforts. So I'm giving you the results of this first, and then we'll dive into how we calculated them. And so the results were interpreted and refined with the help of our steering committee, project partners, stakeholders, and our technical advisory group. So again, any additional comments are going to aid in developing a watershed protection plan that's best suited for this watershed. All right, so to start, again, this is for the general public. So your point source versus non-point source. So a point source, that's defined as something you can physically point at, like a pipe coming out of the ground, and non-point source is the opposite. You can't point at it and it comes from multiple sources. So on the left, we have an example of non-point source coming from your fertilizers that are applied on the land and that can run off into the creek bed and can cause eutrophication and thus algae die-off and fish kill. Down on the bottom left, you have sediment erosion or sediment runoff that can come from a construction site that hasn't been properly managed. And up on the top right, there's an example of a grease container that shows if they left the lid open, an overflow can occur, and grease itself can be detrimental to your aquatic ecology. It can be toxic, form a layer of water on the surface, decrease dissolved oxygen in the water. And then bottom right, cattle. So now the livestock are enjoying a nice cool day, but they're also defecating within that creek system. And as we know, cattle defecation can include E. coli and as well as nutrients. Here's an example of floatables or just illegal dumping, the whole 9 yards. That is also of concern for non-point source pollution. And then finally, pet waste. Alrighty, so the point sources that we identified in Joe Pool Lake, so for our wastewater treatment facilities, we found that there are 13 wastewater dischargers, but there are 5 that are inactive. 1 is a municipal discharger, 3 are package plants for mobile home parks and public school, independent school districts. There are a few that are coming online, but those are in the works. So the significance of this is that both Walnut Creek and Mountain Creek contain some portion of treated wastewater effluent in their base flow. For SSOs, or sanitary sewer overflows, those occur when pipes are blocked, broken, or when deteriorating pipes and connections allow your stormwater and groundwater infiltration into that wastewater system. And so these can overflow and head into our surface water. So we found that there were 39 SSOs that were reported between 2016 and 2020 within the Joe Pool Lake watershed. So going into non-point sources, so our septic systems. So we have found that, there are several unincorporated and rural areas in this watershed where your septic facilities are going to be used for your residents for wastewater treatment. So when they are not functioning properly, they are your source of pollution for E. coli, nutrient solids, both in your groundwater and surface water bodies. Now, there are the permitted septic systems, and then we have our estimated non-permitted septic systems. So prior to 1989, they were not regulated. So since 1989, the counties, your designated reps, those are folks that are responsible for maintaining these records of the permitted septic systems. So the non-permitted systems that might have been lost in the weeds or just haven't been installed properly or just not inspected, these can pose a critical failure. And we worked with our steering committee to come up with a 50% failure rate for those that are non-permitted and a 12% failure rate for those that are permitted. So the ones that we know exist are 4,756 that are permitted within the watershed. And then we estimated 2 to 1. So based on literature, it's estimated that for 1 permitted in the region, there's most likely 2 that are non-permitted. And so that gave us a total of 14,000. And then we further reduced the potential for runoff into our creek systems with a 330-foot buffer. And so the ones that we want to address are within this 330-foot buffer. So 115 that we know of that are permitted are within that buffer, and we estimate approximately double that. So 230 are within that buffer without a permit. So another non-point source, pet waste. So as was discussed, so feces from pets, they're going to be your source of E. coli and nutrients that are loading into water bodies via stormwater runoff. And so from our research from the American Veterinary Association, it was determined that there's approximately 1.6 dogs per household and 1.8 cats per household. So what we determined was that there's approximately, oh, forgot a number there, 29,000 cats and approximately 38,500 dogs. Click. So from our non-point source from Livestock, and these estimates were pulled from the United States Department of Agriculture, the National Agricultural Statistical Survey, and these numbers were pulled from 2017. So the amount of cattle that we found in the watershed was about 11,165. For sheep and goats, we found that there was almost 2,000. And for horses, the USDA estimate was 1,077, but our stakeholders agreed that those population counts should be increased for horses based on those small acreage hobby farms that aren't necessarily included in that National Agricultural Statistic Survey. All right, for non-point source for wildlife and feral hogs. So over here for deer, this is our Texas Parks and Wildlife Department annual median density estimate, and the DMU is your deer management units. And so Texas Parks does analyses, and the 20, 21, and 22, those are areas that are overlapping in Joe Pool Lake. And so that estimate came out to 902 deer. For bird species, this was looking at Joe Pool Lake specifically. So based on an eBird survey that is also analyzed by Texas Parks and Wildlife, they came to a count of 158 that have been spotted. There's definitely more, but that's just based on folks reporting what they see while they're out there. And then with feral hogs, this estimate is brought to you by Texas A&M, and they estimated about 593 in the watershed. So other non-point sources that stakeholders wanted to also address are illegal dumping, floatables, and yard waste. And these are important pollutant sources because they bring in E. coli nutrients as well as other toxic chemicals and can also harm your wildlife. And if the disposal is recurrent and removal and cleanup is infrequent, then it's going to be a huge problem. So the over-application, it can lead to your excessive buildup of nutrient fertilizers, pesticides, and herbicides in those spaces. And so the stormwater runoff is going to carry everything into that water body, usually via storm drain, and it will build up and cause inevitably eutrophication and fish kills, as well as other detriments to your wildlife. Alrighty, so moving into chapter 5. Okay, don't see any questions on what we've identified. All right, so the methods that we utilize, and this is in the modeling report for you to dive into detail on. We use Lotus, which is a load estimation program. We used, well, backing up, how did we get all this data? So we did routine and flow bias water quality sampling. We then used Lotus, then we used load duration curve analysis, and this was based on the collected data for those multiple pollutants. We then, we also, in building those load duration curves, we had to build flow duration curves. And these were based on the data from the stream gauges and in-stream sampling. And then we also used SELECT, which is spatial analysis of potential E. coli sources. And it is a spatially explicit load enrichment calculation tool. Tongue twister. And finally, we use SWOT, so your soil and water assessment tool, and that is for our hydrological modeling. So again, you can touch on all of these specifics, read through everything in our modeling report. So for a low duration curve, that helped us analyze the measured stream flow and corresponding water quality concentrations to assess the water quality standards or screening levels established by the state, by TCEQ, as well as the reference criteria established by EPA that may not have yet been adopted by TCEQ. And the low duration curve also helps us assess when, meaning during what flow conditions. So high flow, show the screen, high flow, moist conditions, mid-range conditions, dry conditions, or low flow, when that water quality standard has been violated or a screening level has been exceeded. So if it's identified during this mid-range to high flow, it can be attributed to non-point source runoff. And there are small to heavy storms that cause significant runoff, and it's going to be picking up the bacteria, nutrients, potable sediment, for example, and carry that into the stream. So this also aids in identifying the best types of our best management practices that can be implemented to mitigate the pollutant loadings in these streams. And the low duration curves produce and help calculate how much of the pollutant needs to be reduced in order to obtain or meet that water quality standard or nutrient screening level listed for the streams. Okay. So our water quality data was used by was collected from January 2013 to April 2020, and these were what were used to formulate our low duration curves. And we pulled them from 9 monitoring stations, or we pulled them from 20 monitoring stations, but only 9 monitoring stations had enough data points, as well as paired flow data for us to properly create or calculate a low duration curve. So we compared the different stations, we focused on the sub-watersheds that corresponded to the specific stations, and we looked at the increases between the stations. So what type of land use or pollutant source contributed to an increase in loading. And we also compared data within one station and looked at the maximum allowable load and determined by that established standard or screening level and determined where the problem may lie. So it could either lie in our high flows, our moist conditions, mid-range conditions, dry flow, or low flow. And so just so you're aware going forward, the steering committee, we did agree to select the mid-range conditions as our flow regime for our water quality improvement goals. So in short, here is a snapshot of what we found based on our low duration curve analyses. So the geomeans of orthophosphate phosphorus and total phosphorus at all 5 flow conditions for all the 9 stations were below the TCEQ screening level of 0.37 milligrams per liter and 0.69 milligrams per liter. And also orthophosphate is no longer used as a screening level concern for the TCEQ. The geomeans of nitrate and nitrite for one station exceeded the TCEQ screening level at 1.95 milligrams per liter at all flow conditions, and one station exceeded the screening level only at high flow conditions. The geomeans of total ketol nitrogen, or TKN, for 6 stations exceeded the EPA reference criteria 0.4 milligrams per liter at all 5 flow conditions. One station exceeded the criteria at low flow, one station exceeded at dry and low flow, and one station exceeded at dry conditions only. So the geomeans of E. coli for all 9 stations exceeded the maximum permitted limit, so 126 most probable number per 100 milliliters of water at all 5 flow conditions, with one exception during low flow conditions. And I can show you the site, 16433. I have a map up here soon. So just so y'all know, Lotus that was utilized in this. So this is a program and standard practice that's used by the USGS to analyze the available observed data sets. So adding them with the daily stream flow data to estimate the low. So, you know, we don't go out there and observe the data for every hour of the day. So most of these samples are grab samples. So that data does have limitations. So we extrapolate that data and we use stats to do a regression analysis to estimate the load, the daily load, and then an annual load, and then outliers are removed and we use the 90th percentile. Alrighty, so here are our monitoring stations. So Lotus can't use any of the stations within the body of the lake here, so we need a paired stream flow. So the green diamond overlaying the red box here, those are all the monitoring stations that we used for the load duration curve assessment. And then we have two USGS gauge stations, so 13621 on Walnut Creek and 13622 on Mountain Creek. So since we didn't have continuous stream flow data in all of these monitoring locations, we used the soil and water assessment tool to calibrate the daily stream flow against the USGS station data, observed data sets for 30 plus years. And then we use the daily stream flow to estimate for the other locations where we didn't have that daily observation. And this helped to develop the load duration curve. So also, we ended up breaking, and I will show a map, we broke this up into 25 subcatchments. And so anything that falls in the Walnut Creek subcatchment is prefixed with WC. Anything in the Mountain Creek area is prefixed with MC, and anything in Soap Creek is prefixed with SE. All right, looks like we had some more people jump on, so we'll add in sign-in information. All right, so land cover in Joe Lake, this is based on the 2016 National Land Cover Database, as well as the 2017 to 2019 agricultural data set. And the ag data set's updated annually, but the NLCD is not. So this is the most recent data we have. So there's about 41% that's covered by rangelands and pasturelands, 17% by forest, 25% by urban, and 6% by open water and wetlands, and then 10% by ag lands. So as we go along, keep this image in mind when we're discussing these modeling results. So we also broke down the land cover distribution above each monitoring station. So for example, Station 2213, which is in the Grand Prairie, Arlington area, as you can see, red, this classifies it as heavily developed, so majority urban. And then as we go down over here, for example, 16434, which is south of the 360, near like south of Mansfield, going towards Midlothian. And this is majority cropland, grassland, ag land. So, whoop. All right, so here is one example that I'm going to cover. The remaining are in that report because in the interest of time, I want to make sure we go into detail on our best management practices. But here is the load duration curve and loadings developed for monitoring station 13621. So this is at Walnut Creek, in Walnut Creek at Matlock Road, and this is also where a USGS gauge station is. So the geometric mean of E. coli here, so you can see all these blue dots, this represents the observed load, so actual samples that were taken, the estimated load here, regression curve, and then this is the permitted load, so it's the 126 MPN standard with a margin of safety, so 10% of that, so we are looking at 113. Most probable number here, and as you can see, it's significantly greater than what is permitted within that body of water. So it essentially exceeds it at almost every flow condition here, 100%. And I did note earlier what we ended up going with for our water quality improvement goals was the mid-range condition. This is what was most economically feasible, and also it's the permitted load, the 126, Faith. I might be mixing up my words right here. Okay. Faith, if you can expand on that, I'll get back to you. So essentially, the permitted loading here, based on the 126 most probable number, would be paired with the flow is the 1.05 times 10 to the 10. And then your daily loading, as you can see, exceeds that. Percent daily load reduction needed would be 99%. This is your annual loading and most probable number per year, and then your reduction needed. All right. So here's a summary of the TCEQ water quality standard exceedance at different flow conditions for E. coli. So it is high during the high flow, moist conditions, and mid-range conditions, which does indicate your runoff containing non-point sources such as pet waste from urban areas, livestock waste from rangeland, pasture lands, and wildlife waste from your forested areas. And it also exceeded the water quality standard during your dry and low flow conditions that also indicate non-point sources, but could include point sources such as your septic facilities in rural areas. So the summary of the water quality screening level exceedance for NOx, and so this is in Soap Creek, and the exceedance here was exceeding in your low flow, dry conditions, mid-range conditions, moist and high flow conditions. And this may be due to waste from livestock like your cattle, sheep, goat, and horses from those upstream rangelands. So based on that land use. And we also opted to voluntarily include your the TKN reference criteria, which is from the EPA. And so here's the summary. And again, TKN, that's the component of total nitrogen. So it's your sum of organic nitrogen and ammonia, which comes mainly from animal manure. So here at 16,434, it was during that high flow conditions. We believe it's coming from, potentially feral hogs and deer upstream in the forest, while in Soap Creek, 22134 and 13622, Elver and Walnut Creek, this can be caused by livestock grazing on rangelands and pasturelands upstream of the monitoring stations. And additionally, the loading here during low flow, that may be due to septic facilities and potentially wastewater treatment facilities. So we have opted to include TKN as a water quality improvement goal, or reducing TKN. All right. So our water quality improvement goals here, they were determined by each individual load duration curve analyses, and the mid-range conditions were what were selected for flow as it is seen most commonly in the area, as well as the most feasible to mitigate those loadings from non-point source runoff. The most downstream station was selected in each of those sub-watersheds. And like I noted before, TKN were voluntarily choosing to address this nutrient of concern. So in coming to our totals for nutrients, and if there's a problem with this, we can adjust this, but this was the idea that we had with our steering committee, was since NOx is greater than TKN in Soap Creek, we're just not gonna touch the TKN loading and only address, well, essentially these BMPs that we're gonna be putting in place are going to address both TKN and NOx, but to come to a total nutrient loading that we were going to address, we just subtracted the 7.82, so 7 tons, and only added together the NOx here and then TKN from the remaining watersheds to come to a total of 18 tons per year, so 1.86. If this doesn't seem right, if we should just include this and add this, then we can do that too. Let me know if we need to do that. And then for E. coli loading during the mid-range flow conditions, we took the 7.7 times 10 to the 14th, added to 5.37 times 10 to the 14th, added to 9.8 times 10 to the 14th, added to 5.7, et cetera, and so our total loading for our water quality improvement goals, so we want to reduce it by 2.42 times 10 to the 15th. Alrighty. All right, so any questions on any of that before I jump into select and RBMPs?
Just have one question on evaluating E. coli. Should you be looking at the geomean or should you be looking at the grab sample E. coli concentration? 126 versus, what is it, 350 something or 380? I can't remember what the single grab sample is.
Oh, yes, we're looking at the geomean.
I know, but is that proper?
Is that proper?
Yeah, is that the way to do that? Or should you?
Oh, yes, because we're going to be continuing sampling over a certain amount of time. And so in order to understand the cumulative reduction, we would look at the geomean. So a grab sample, is just a timestamp, timestamp in time. And we want to see over a time period. So therefore we would be going with the geomean. We wouldn't be adding up all the grab samples, or we wouldn't be looking at the individual grab samples. I don't know if I addressed that right. But the TCEQ looks at the geomean for meeting the state permitted 126 MPN, and that's what determines if it's impaired or not impaired. So that's what we'll be looking at. So another interactive, not able to load. I'm going to send you this map so you can interact with this as I go through select. And the layers are going to be on your left-hand side, and you can open, so you have to hit the eyeball if you want to show the layer or hide the layer for this map that I just sent in the chat. Okay, so quick refresher. So what is select? So this is our spatially explicit load enrichment calculation tool. And it's not a model, it's simply based on the GIS and correlated to land use and population data. So essentially how many cattle, deer, cats, humans would be on these specific land uses above each of these monitoring stations. And so this is a potential, it's not what actually happens. This is hypothetical, worst case scenario. It doesn't account for natural mitigation by land or by anthropogenic uses. And it's used to provide a potential load of E. coli bacteria. And so we then use literature values for your fecal production rates. And again, worst case scenario, so this is where we had input from our steering committee and stakeholders to determine if the numbers we calculated seem reasonable. And so I already went through all those numbers. And so if you think we should modify, increase, decrease some of those, please let me know. And so here's just an example of the visual output that Select does provide. So this example is feral hogs, and it can be deer, cats, anything, cattle. So it evaluates those selected pollutant sources separately, and the output is spatial. So it spans this whole watershed. So red is going to be something that is of a high potential loading into our creek system, and green is going to be something that is of a low potential loading. And so this helps us determine the target areas for these potential management practices that we will discuss, and to meet our water quality improvement goal that came from our load reduction curve analysis. Alrighty, so revisiting this, so worst case scenario, we know that not everything produced on this landscape is going to make it to the river. So the distance from the source to the stream isn't taken into account automatically. So Texas A&M, who was our contractor that worked through this, they created a buffer zone of 100 meters or 330 feet to show that anything within that buffer zone is going to have more influence and reach the stream versus outside of that buffer zone is going to have less influence and most likely not reach the stream. Alrighty, so these are our catchments. We developed 25 catchments within the watershed. So recall Walnut Creek is going to be prefixed with WC, Mountain Creek that goes into the Mountain Creek side of the arm, prefixed with MC, and then we have Soap Creek with SC. And then we also have Joe Pool Lake, and that was included because of the riparian buffer, as well as the avian bird surveys and wildlife. All right, so I already talked about the populations that we came up with, but this is how we did it. So in order to estimate these load contributions, we calculated the population in each sub-watershed and how these populations were distributed across each land use. So for example, deer, they weren't going to be included in urban areas. Same with cattle, and we distributed those respective animals and sources to a limited land use type. So cattle to range, pasture land, pets to urban areas. And we use that to target what is driving the pollution contribution, but also how to assist with our future resource management and mitigate the source. So we looked at multiple populations. And so we had brought this to our steering committee and we agreed this was a good list. If you think we're missing something, please let us know. So these loading rates, these are, what the potential E. coli loads are produced from these specific sources. So this production rate comes from literature, mostly comes from the EPA. So for example, if you have 1,000 cattle and you multiply it by their fecal production rate times per day, times per head of cattle, then you'd come to what your E. coli loading rate would be. So you take the number of animals in a particular subbasin, distribute it across its limited land use in that subwatershed, and then you would have your loading rate. And so some of these sources are going to be differing by an order of magnitude. So you see 10 to the 9 or 10 to the 8th, but comparing cattle with pets, see 2.5 times 10 to the 9th, 2.7 times 10 to the 9th, they are pretty similar. And so you'll find that pets and cattle are ranked high on our priority list to address. Alrighty, so going into our results. So I touched on all the population counts, and so now we're going to talk about total potential E. coli loads and the highest priority watersheds. So for cattle, the highest priority watersheds are going to be up in your Mountain Creek upland area, Walnut Creek upland area, and it's pretty much the highest are going to be in red. Same with sheep and goats in similar watersheds, and same with the horses. But since we did add those hobby farms, we found that it would be most likely in this region, which is inside of Mansfield, and also up here in Midlothian and out into Venus area, etc. So for wildlife, our priority highest priority watersheds are also going to be in red. And, you know, I will get to how we ranked what we're going to focus on, but priority here is just based on what the total potential load could be. So deer were going to be found in the Walnut Creek watershed mainly, as well as in the forest and some rangeland. Feral hogs are mainly going to be found in your riparian buffers out over here, and this is the state park. And then your dogs and cats, this is mainly in your urbanized area, and this is going to be like North Mansfield, Arlington, Grand Prairie, and then some unincorporated area. For your septic facilities, we found that a majority are going to be in this Rendon, unincorporated Tarrant County area, and then also down here, which is Ellis County, Johnson County borderline unincorporated area, as well as some in Midlothian. And then for wastewater treatment facilities, now this is a little biased, but this is pretty much the locations where they're found. So there was only 5 that are actually permitted. So therefore, this is just showing it could have a high potential loading, but that doesn't mean that they're actually causing an impairment. It's just that this is the majority are located in this region. And so when you combine everything and you look at your total potential E. coli loadings, we found that the highest priority watersheds in red are going to be north in the Walnut Creek, in the Jopa Lake watershed in the Walnut Creek area. And so this is summarized for you guys to review later. Okay, actually, looking at this, this is how we came up with this rank. So this ranks everything by the annual potential E. coli load per year. So pets ranked number 1, they were the highest contributor. Livestock was number 2. Septic facilities were number 3. Feral hogs were number 4. Wildlife was number 5. And wastewater treatment facilities ranked at number 6. Things that were unable to be ranked but were requested to be included were yard waste and residue, sanitary sewer overflows, and illegal dumping. So working with stakeholders, we prioritized how we wanted to tackle implementation of best management practices. And so our priority paired pets with yard waste and residue. So this will be tackling nutrients and E. coli. And then second priority was going to be tackling livestock. And then our third priority was looking at septic facilities and pairing that with illegal dumping and floatables. And our fourth priority was going to be looking at SSOs and wastewater treatment facilities. And then our fifth priority would be looking at wildlife and feral hogs. And so the feral hogs and say something. Feral hogs and wildlife were put at the bottom of the totem pole because there really weren't that many in our watershed, and they can be they can exceed feasible management. All right, so another depiction of our priorities. So first priority will be your pet waste and yard waste. Second priority is livestock. Third priority, we have our OSSFs and illegal dumping floatables. Fourth priority, looking at wastewater treatment facilities and sanitary sewer overflows. And fifth priority, looking at feral hogs and wildlife. All right, moving into management strategies. Looking at the chat. Yeah, Robert, so looking for egret nesting and other dense bird populated areas. So Texas A&M utilized what Texas Parks and Wildlife provided. And that was the most reasonable way to try and determine the amount of birds. But if you know of certain areas, I mean, it would really take us going out, counting, and then trying to determine an appropriate E. coli loading rate for those birds. You know, are they transient or are they resident? So it is something to consider. Okie dokie. So here is our summary, and this you can, I believe you can find it in our the BMP recommendations that I sent over. Should be in there. If not, it will be in our draft chapters that I will send out after this. Alrighty, so these reductions are watershed-wide E. coli loading, and this is the primary goal of the Watershed Protection Plan. And steering committee, we also chose to incorporate other water quality related goals along with some unconventional measures. So in other watershed protection plans, education and outreach become prominent components, like Jessica pointed out, and they are effective means of achieving the pollutant reductions, but sometimes they can't be quantitatively measured. But it looks like I need to see some of those results for those load, those counts that Jessica was talking about to see how that works. But before and after surveys can be used to show like tested knowledge and test their knowledge to see what has been gained. But it can't necessarily predict what those attendees will actually put into practice. And any water quality improvements from the education outreach initiatives will all run parallel. So I don't really note them in here, but they're running parallel with these implementations. All right, so we're going to be targeting animal waste volumes sometimes through population control, which can provide direct and significant reductions to E. coli loads. And another way is using activities to correct and remove sanitary sewer overflows, as well as malfunctioning septic facilities. And we can provide some relief for systems stressed by that. So the overall anticipated load reduction provided by these management measures. So if you look at pet waste, an idea would be to look at pet waste disposal ordinances, install supplemental pet waste stations, so doing recon, coming up with doing site surveys and looking at areas where bioswale and rain garden projects to go into place, installing backyard pet waste digesters, and that would equate 2.3 times 10 to the 15 most probable number per year for an E. coli load reduction. So without reading through all of these, because I'm going to read through them individually. Looking at your total here, so 2.3 times 10 to the 15th, jumping down to livestock, 1.8 times 10 to the 15th, plus septic facility reduction of 4.7 times 10 to the 12th, plus feral hogs, 1.2, equates to a total anticipated E. coli load reduction of 3.4 times 10 to the 15th, and that surpasses the loading reduction or water quality improvement goal of 2.42 times 10 to the 15th. And then with nutrients, we are hoping to put in significant green infrastructure that, as well as conduct illicit discharge surveys and address or assess lawn waste management ordinances. And we anticipate our nutrient load reductions to be 1.86 times 10 to the first, and I will talk about how we came to that number. Most of the best management practices that we put in to address E. coli loads will address nutrient loads. Okay, so let me pull up the strategies that have been sent out to you. All right, so recommended BMPs for pet waste. So as we know, concerns are improper disposal of pet waste, lack of education on impacts improper disposal, and disease transmission and public safety. So our goal is to reduce the E. coli load from pet waste delivered to water bodies through stormwater and irrigation runoff through management of E. coli loads, representing 20% of this present pet population. So we had about 65,000 pets that we calculated, and 20% of that is 13,451 pets. So our objectives are to increase education and outreach efforts pertaining to proper disposal of pet waste and provide opportunities for proper waste disposal and abatement. And so these calculations came from estimates that Hog provided through their co-op program. And we're going to be looking at additional avenues since utility bill inserts aren't really used anymore. And calculation for reconnaissance comes from salary, and then installing new pet waste stations, the 300 station that came from a pet waste company. And this was calculated based on how many collection bags are in a pet waste station. And that was multiplied together to come to 40,000. So based on the pet waste bags, you can determine how many dogs you might address. And then with pet waste digesters, this is just based on quotes from install and equipment to build. So the BMPs recommended for pet waste, we seek to combine the waste to a landfill, treat waste on site in the ground. In doing so, the amount of E. coli from pet waste sources entering the waterways via runoff from rainfall or irrigation will be reduced. And it's reasonable to assume that not all of the deposited waste can be removed via bagging and burial. So a 75% removal efficiency will be applied to that load reduction. And similarly, it's expected that the recommendations will likely only capture loads from 20% of that present pet population, so 13,451. And so with that 75% removal efficiency, a 15% reduction is expected. So the results estimate that a total annual pet waste reduction of 2.3 times 10 to the 15th is feasible for that managed pet population. All right. So for livestock, concerns are so I talked with Michael Brooks yesterday, and I didn't have enough time yesterday, but I'm going to be aligning these with their resource management priorities so that it can aid in applying for that type of funding when we go forward with implementation. So I just wanted to shout out to Michael for taking the time yesterday to go through that with me. But essentially, we are going to be looking at overstocking of animals that can result in overgrazing, degradation of riparian buffers, stream bank destabilization, and disturbance of aquatic habitat. And so the goal is to reduce E. coli from livestock through education and by encouraging participation in the water quality management plans and conservation plan programs that are run by the NRCS and the Texas State Soil and Water Conservation Board. So with projects focused on minimizing the amount of time animals spend in riparian zones by improving resources across the property. So now I still need to talk with a few people, but it seemed that trying to implement 52 water quality management plans and conservation plans is reasonable. It will take some time, and this is why we would apply for funding to hire a technician to aid in that outreach and planning and building of the plan. But this is the number, 52 properties, and the cost came from the average head of cattle in Joe Pool Lake, the average farm in Joe Pool Lake, and what else? I'm missing something. But all I know is that does seem reasonable. I still need to talk to two other people from the Soil and Water Conservation District, but it looks like this is a go. So pretty much adherence to prescribed whole farm management plans like WQMPs and CFPs that's expected to reduce E. coli loading to streams through indirect, so fecal contamination and stormwater runoff, and direct fecal deposition into streams. Improving the land cover management and limiting the time spent by animals in riparian zones are expected to provide a total annual E. coli load reduction of 1.08 times 10 to the 15th. And this was done by calculating head of cattle, so 20% of that population. So there's 11,000 cattle, so we'd be focusing on about 2,000 head of cattle, and then implementing rotational grazing, exclusionary fencing, for example, as well as alternative water sources. So this is all also based on cattle, and this is because the cattle are 78% of the livestock species in the entire watershed. Okay. All right, so I did pet waste, livestock. I'm gonna go in order here. So let's talk about nutrients. Alrighty. So what we have here, how we want to address this. So I put a lot of the green infrastructure quotes under this, but green infrastructure is going to fall under all the different pollutant source populations that we want to address, but I mainly quoted it under here. And okay, I'll get to how I made that. But so concerns with lawn residue and waste. So we have improper disposal of organic lawn waste. We have excessive fertilizer, herbicide, pesticide, or other chemical application on lawns and other open areas. And the impact is the direct, indirect contamination of water body from E. coli, nutrients, and hazardous materials, and impacts to aquatic life. So our goal is the reduction of nutrients sufficient to reduce TKN and NOx loading in the Joe Pool Lake watershed. So our objectives: increase education and outreach efforts pertaining to proper handling of organic yard waste, promote use of residential commercial lawn management, conduct illicit discharge surveys, and identify and install green infrastructure in coordination with cities, counties, and property owners. And it is not all inclusive. There'll be a lot more folks we would need to work with. So down here, so identifying and installing green infrastructure BMPs as funding becomes available. All right, so I looked at two different studies, actually three different studies. So one was in Texas, one compiled studies from all over the US. Actually, two of them did. So, but I'll talk about the one in Texas first. So this study was done by Dr. Srini, Dr. Jabber, and two others. Their name is lost on me at the moment. But essentially, they implemented rainwater harvesting, impermeable pavers, and rain gardens in 20 to 34% of an urbanized area with roofs and 31 to 45% of properties in an urbanized area with parking lots. And so their estimated reduction in their surface runoff varies from 14% to 29%, and the reduction in nitrate runoff varies between 24% and 30%. So in another study done by Clary and Jones, so the Urban BMP National Database, so they looked through and they looked at studies nationwide where you installed pervious pavement, rain gardens, bioswales, and bioretention ponds, and that reduced pollutant loads by 25 to 100%. So based on where these BMPs would be put in place, it is expected that we would at minimum see a 50% reduction, and what we need to see is 53% watershed wide. And this is going to vary, and because it's going to depend on the type of infrastructure we put in and the maintenance, but this is a large goal. So we plan to work on this, or include this as a top priority, since nutrients and E. coli coming from pet waste and lawn waste residue has been ranked as #1. Alrighty. So costs, how did I find this? This was estimated from one of the studies from the Urban Stormwater BMP Library. So it could range from $6 to $45 per square foot. And this a lot of these studies were done in the Northeast and Northwest. So it could be cheaper in Texas, I don't know. But this is just an estimate, and it can range per acre from 200,000 to $1 million, depending on what we wanted to do, what we wanted to choose. Like pervious pavers, $6 versus like a wetland, $45 an acre, or sorry, per square feet. And I can share these our literature with you. All right, any questions on that before I jump into the other ones? All right, so septic facilities. Okay. So our concern, direct and indirect pollutant loading from failing or non-permitted septic facilities, and disease transmission and public safety. So our goal is we want to reduce the E. coli load from septic facilities delivered to water bodies directly or indirectly through education, outreach, and incentivized inspections to yield a 15% reduction in the number of deficient systems. So our objective here, increase education and outreach efforts pertaining to proper maintenance of septic facilities, provide access to affordable inspections and pump outs for at-risk septic facilities in the watershed. All right, so these estimates, this came from Texas A&M, since they mainly provide these homeowner-focused OSSF care maintenance trainings. And then inspections, those came from a majority of sources that I can share with you. So if you incentivize the inspections with the pump out for the property owners with those at-risk systems that have not been recently inspected, it could equal half cost for 50 inspections at $325 an event over 10 years. And then here, so provide practice-focused training for awareness of pollution potential, local ordinances, and importance of routine maintenance and cleanouts. So yearly, and this is about $7,500 an event, which is how we determine the cost here. And then we also have other recommendations. But how we estimated it, so the efforts involved, Efforts involve the BMPs focused on the OSSF owner education and incentivized inspections targeting at-risk OSSFs with priority given to those located in riparian buffer zones. So by applying the recommended BMPs listed above, a 10% decrease in the reduction of failing systems is expected, and resulting in an E. coli load reduction rate of 4.7 times 10 to the 12, and you apply an attenuation factor for the natural land. And you use that in other reduction calculations, and you get your expected load reduction. So we had 115 OSSFs and 230 non-permitted. So we're looking to try and address like 15 septic facilities that are failing. All right, what else do I need to? Okay, feral hogs. All right. So the concerns are the uncontrolled proliferation of feral hogs in the watershed. The goal is to reduce the feral hog population by 5% in the watershed, so by 30 hogs, and prevent further population increases. So all of these numbers came from Texas A&M, and in doing so, the calculations would, if we remove 5% of the population, I need to change a few of these numbers, then we would have a result of 1.2 times 10 to the 13th, most probable number per year. All right, I've gone over a lot. Let's see, what else do we have on here? So what other questions do we have before I wrap up? So I'm going to send a lot of this out to you, and I will need some feedback if you have it. If not, great. So anything that I need to touch on or go back to? So Elena, I don't need actually anything specific from anyone. It's just if they have any ideas for adding any numbers to population counts or concern with how I calculated some of the BMPs, then I can address that, or I can do that one-on-one. So really this was just me getting the word out that we have finalized everything and that we will be sending out a draft watershed protection plan by the end of October for public comment. All right, so our best management practice recommendations have been given to you today. The steering committee will now consider any input that y'all have put in from today. We'll finalize those BMP recommendations, as well as funding sources and measures of success by October 13th. And then I will send out a final meeting for October 20th to everyone, and then send out a watershed protection plan draft for public comment and TCEQ review. Okay, and then I just have one notice that we have an upcoming workshop October 14th in Mansfield for urban stream restoration training, and you can access this link. So after I send out the PowerPoint, you'll be able to access everything here. All right, any questions?
I have some questions, please.
Huh?
I have a question.
Okay, sure.
So I always chime in at the very end about my project, and I'm upscaling. Gave a program a couple of months ago at the North Texas Central Council of Governments on the Trinity River bioremediation demonstration project, and that involves using agricultural byproducts that are inoculated with microorganisms that will help break down contaminants in soil and thus improve our watershed. Recently, I have scored a job, and that is involving how to process 10,000 gallons of organic waste pressed off of onions to do the same thing that I'm doing with my microorganisms in the Trinity River. So this is not an approved BMP. I'm trying to get it as an approved BMP. That takes a while, but I am actively looking for farmers, dairy farmers, cattle farmers, ranchers in the watershed that aren't directly connected to an open waters of America to offer some of this product, as to be able to break down contaminants as they are running off and going towards our waterways, as well as other applications. Fertilizer, the price of fertilizer price has gone up. My product is basically just like it always has been, fertilizer, or it's not a fertilizer, it's a like a compost. And I believe this will be very effective and start us on a path to what are we going to do with the rest of our organic wastes being produced in large factories all over town, all over the world, instead of throwing them in the landfills or other various places where they can be thrown, but to put them to use. So my question to you is, even though this is not an established BMP, I realize that that it might not be established for at least a couple more weeks. Could take longer than that. How would I, what is the process now between my upscaling to something that could actually be a significant contributor to breaking down the E. coli as it's coming into our Joe Pool Lake watershed, and where I am now, and where I would like to go to have this as an established BMP for this plan, please?
I mean, so a best management practice, I mean, everything that I've pulled is based on literature and proven results. So maybe Aaron could chime in on that. He's still on the call.
Sure. When we say approved BMP, that just means approved by your stakeholders. As Heather kind of alluded to, as long as there's some technical rigor behind it that shows that it, has results to it. That could, in and of itself, be approval of a BMP, as if your stakeholders buy into it and your regulatory agencies either shrug at it and say, okay, fine, or give it the thumbs up. I think that's really what constitutes an approved BMP. So the real crux of getting an approval is, to get into that list of BMPs for that watershed. What works in one watershed or is approved in one watershed may not be approved in another, just because it doesn't work in that area because of soils, climate, things like that. So as far as any official list, Virginia, you're looking to get on for that, I don't know if that necessarily exists. It's just a matter of getting the buy-in from your stakeholders and the regulatory agencies. So I hope that starts answering your question.
It does. And I know that even though I'm at the kind of tail end of this thing, is it too late for, I heard Heather say that it's okay to do other recommendations. Is it too late to recommend this for this plan?
Well, if you send us the research, I can send it out to the steering committee and the stakeholders and see what they think. And we look at the loading factors and try and put it into a water quality improvement goal.
Awesome. I hope I have a solution.
Yeah.
I'm pretty sure I do.
All right.
Thank you.
Yeah. Okay, so that was a lot of information. And I lost my voice throughout half of that. So let me know if you have any comments. I sent you the documents. Please look at those BMPs. I will send out the chapters probably tomorrow. I'm expecting any comments back from our steering committee, and then y'all can go through that with all of the text that supports the BMP decisions. And that is all. So thank you very much. I appreciate you all attending today, and this will be posted.
Thanks, Heather.
Thank you.
Thank you, everybody.
Thanks, Heather.
Thank you.